We come now to our second form of inductive inference, statistical syllogism. Remember that a syllogism is defined as an argument with three lines, two premises together with a conclusion. In a statistical syllogism, a certain property is ascribed to someone or something because that same feature is found in the class to which the person or thing belongs. Here's an example. Premise 1, most professors have doctoral degrees. Premise 2, Ms. Williams is a professor. Conclusion, so Ms. Williams has a doctoral degree. Let's examine the structure of statistical syllogism more carefully. First, note that the first premise uses the quantifier most, so the statement is a non-universal generalization. If it said all professors, it would be a universal generalization, which would lead to a conclusive inference. That's not the case here. The form of the argument is as follows. Premise 1, most P's are D's. Premise 2, W is a P. Conclusion, therefore W is a D. This is a syllogism. It's an argument with three lines, two premises together with a conclusion. It uses a non-universal generalization in the premises, a specific statement in the second premise, and another specific statement in the conclusion. Note that it ascribes a certain feature, namely possession of a doctoral degree, on the basis of Ms. Williams' classification as a professor. Here's another example of a statistical syllogism. Premise 1, 80% of firefighters have some EMT training. Premise 2, Jones will be a firefighter, so conclusion, Jones will have some EMT training. This argument structure is essentially the same as our first example, except that we have substituted a percentage, 80%, for the word many. But it's still a non-universal generalization that ascribes a certain property, EMT training, to a category of persons, firefighters, and then places Jones in that category. So it's pretty likely that Jones will be prepared for handling a medical emergency.